This is naphthalene. Note its appearance. I have placed some naphthalene in this test tube and I will heat it in boiling water to see if it melts. As you can see here, the naphthalene melts at 100 degrees Celsius. In this test tube I have placed graphite from pencil in butane 2-ol, and you can see that it has not dissolved. In this test tube I have placed graphite in hexane, and again you can see that it has not dissolved. Now I have added a strip of magnesium to butane 2-ol and a strip of magnesium to hexane. As you can see, in both of them magnesium is insoluble. I have placed equal amounts of naphthalene in water, butane 2-ol and hexane. None of the naphthalene is soluble in water. However, a small amount is soluble in butane 2-ol, but most of it is soluble in hexane. So we can say that naphthalene is insoluble in water, slightly soluble in butane 2-ol, and soluble in hexane. I have added 4.1 grams of common salt to water, to butane 2-ol, and to hexane. As you can see here, the salt is insoluble in butane 2-ol and in hexane, but in water most of the salt has dissolved. So we can say that salt is soluble in water but insoluble in butane 2-ol and in hexane. In order to measure the conductivity of a substance, I will use the multimeter. First, I will have to ensure that the black lead is plugged into COM and the red lead is plugged into volts or ohms. Then I will move the function switch to 2000 ohms in the lower left. I will now measure the conductivity of a strip of magnesium by placing the leads across the strip of magnesium. The LCD display reads 0, indicating that the resistance of magnesium is 0 ohms. Or in other words, magnesium is very conductive. I will now measure the conductivity of naphthalene by placing the leads in naphthalene. The LCD display reads 1, indicating that naphthalene is not conductive.